Welcome to my Prisma crash course for beginners. In this video, you're going to go from a complete beginner to mastering Prisma ORM and building a full stack job posting app from scratch using NextJS, PostgreSQL, and Prisma. This course is designed for beginners. Whether you've never used a database ORM before or you're looking to level up your backend skills, you'll learn how to define schemas, query your PostgreSQL database with type safety, and connect everything into a real-world application. By the end of the video, you'll be able to build a website with Prisma where users can browse different job opportunities, post a position online, apply for a job, and even see the status of the jobs they've applied for. If you want to check the code, everything will be in the description. And in order to learn complex technologies like Prisma, you need to have hands-on experience. And that's where today's sponsor, Brilliant, comes in. When I'm building a full stack app like the one we're going to be building in this video, it's not just about writing code. It's about solving problems and thinking clearly about how everything connects. And that's where Brilliant comes in. Brilliant is a learning platform where you learn by doing. With thousands of interactive lessons in math, data analysis, programming, and AI, you'll be able to improve your skills and progress in your career. What I love about Brilliant is that it doesn't just throw lectures at you. Every lesson is hands-on, you solve problems, get feedback, and build intuition. It's 6 times more effective than watching passive videos. It's also great for developing real problem-solving skills. Their algorithms and data structures course, for example, helped me sharpen the exact thinking I use when designing database queries, structuring models, or writing efficient backend logic. And because lessons are bite-sized, it's easy to make learning a daily habit, even if you only have 10 minutes. So to try Brilliant for free for 30 days, head to brilliant.org/PedroTech or click the link in the description. If you click that link, you'll also get 20% off their annual premium subscription. One easy way to support the channel is checking out our sponsors, so go ahead and check out Brilliant. And now let's get into the video. So let's start the video just talking a little bit about what is Prisma and why it is useful. So first of all, Prisma is a very powerful ORM, also known as an object relational mapping tool. So it is primarily used for JavaScript and TypeScript, and it allows you to simplify the way you interact with a database by providing an intuitive and type-safe API. Now, what exactly does that mean? Well, an ORM is a tool that helps you work with a database using regular code instead of writing SQL manually. If you've ever written SQL in the past, you know how sometimes it can get complex and overwhelming. So Prisma and other ORMs allow you to simplify that by using JavaScript functions instead. So for example, if you were to want to make the following query on the screen where you select data from a user's table, instead of writing that SQL statement, you could then use the Prisma API to find that exact data and retrieve it in your app. So why exactly is that useful? Well, there's a variety of reasons why you might want to use an ORM. First of all, it's a lot easier to read and write data because you use the same language you're coding in without having to learn SQL when you're writing your project in TypeScript. Also, it is safer because it prevents mistakes that could lead to breaches like SQL injections. Also, it's faster to develop because you don't have to keep writing repetitive SQL code because you can just use a function for that. And on top of that, there are clear models that Prisma allows you to define in your code, which makes it such that your entire code base is type safe whilst adapting to how your database is structured. So that's all benefits that any ORM has. But why Prisma is specifically the one that I think is the best? Well, Prisma is extremely good compared to other ORMs in 3 primary areas: type safety, performance, and community. And that's why in this video, we're going to be learning Prisma, starting off by just building our first queries and setting up our project, and then actually building a full stack project using Prisma. Okay, everyone. The way we're going to start this is I have this starter project that you can access by clicking the link in the description. This is a simple Node.js Express server that is running. We're going to start the tutorial just explaining Prisma in this very simple environment so that we can then transition into explaining Prisma in the context of using a framework like Next.js and later on even building a project with it. So if you open up this starter, all that we have here is a simple project set up without Prisma yet. It just has simple TypeScript, Node.mon, Express, all that kind of stuff. And there's an index.ts over here, which just generates a simple Express node server. So if I were to run over here, npm run dev, we would run our server and we'll be having access to all the endpoints that we decide to create. Now, in this project, or in any project that we want to install Prisma, we can use the Prisma CLI. So what I want to do in my project is I want to install a couple packages. So the first one is going to be npm install Prisma. And this is just a generic Prisma library, which is going to allow us to create our Prisma databases, which is going to allow us to actually access Prisma as an ORM. But we also have to install @prisma/client, which basically allows us to access and interact with Prisma in our JavaScript or TypeScript project. So I'm going to install both of them. And when they're done installing, we can run the command npx prisma init, and it will generate a lot of the files that we need to actually have Prisma set up in our project. When this is done running, I'll be back. Perfect. So as you can see over here, we have finished generating and our Prisma schema was created. It lists out some of the next steps that we might want to follow, but I'll explain to you guys what we need to do. So the first thing that we get here is this Prisma folder. And this is what is going to include your Prisma schema. So when you click on this, you should see a file like this. Now, if you don't get, the syntax highlighting and so on like I do, it might be because you need to install the Prisma extension. So you just go over here, you search Prisma, and you install this package over here. It is from prisma.io, and then you can have syntax highlighting on files that are of the extension .prisma. Now this file is extremely important because, as the name implies, this is your schema. Not only you will define how the schema of your database tables is going to look like, but also here's where you provide what database you're going to be hosting. So you can actually use Prisma for a variety of different types of databases. Now in this video, we're going to be using Postgres as the provider for our database, but you could use anything you want, to be honest. So we're going to keep it as Postgres over here, but if you're using another database management system, you would replace the provider value over here with whatever you're using. Also, you see, we have to specify what database URL we are going to be using. So where are we hosting our database? For some people, especially if you're using something like Postgres, you might be hosting it locally. But I think that you should be hosting it in the cloud, especially if you're going to be building a project. That's how you usually do it. So in this video, we're just going to be using Neon, which is just one of the free options for providing serverless Postgres databases. So I'm going to show you guys real quick just how to set up your free Neon database, and I'll be back in a second. So you should go to either the link in the description, or you can just go to neon.com and you click sign up and then create your account. You can log in with GitHub, with Google, whatever you want. I'll log into my account, and when I'm done, I'll be back to show you guys. So when you are creating your account, you'll be prompted with this, which is a place for you to create your first project. Now, you need to give a name to your project. I'm just going to call it Prisma course, but you obviously call it whatever you want. And you can choose the Postgres version that you're going to be using. Again, Neon is specific for creating serverless Postgres databases. So that's why it is mainly tailored for Postgres databases. So then you need to choose what your service provider is going to be. I'm going to choose AWS just because I work at Amazon, so I prefer AWS. Then I'm going to choose where. So I'm going to choose here the West because it's closer to me, but choose whatever region you want. That it's probably the better you choose the one that is closest to where your users are going to be at. And we're going to click create project. Then, as you can see, we have this dashboard over here, but the important part is that we can now connect our database to whatever we want. We have here the link to our database that we can just copy and just insert it into our URL provider. So we could just put it directly over here, but as you can see, this is wrapped around by an env function, which means that this will be treated as an environment variable. So you shouldn't be putting your database URL directly into this. You should actually put it into a .env file, which we have it over here. Now, this is not the database that we have. This was auto-generated by the Prisma library when we ran prisma.init or Prisma init. But we're going to delete this and we're going to paste the database that we now have hosting on Neon, and we should successfully set up our database for us to use. Perfect. Now we are ready to start building our first Prisma schema. So a Prisma schema is just a file where we're going to define our database models, relationships, and configuration using the Prisma syntax. So there's a couple important keywords that you need to learn for when you are dealing with a schema in Prisma. The first one is the generator. This basically just tells Prisma to generate the client code you're going to be using on your app. So if we didn't have this over here and we didn't have the Prisma client installed, we would have a Prisma database, but we wouldn't actually be generating type safe values for us to use in our project. So we do have to have it like this. It will generate an output of our Prisma schema into whatever path we pass over here so that we can then access that in our project. Now, the second one is the data source. And a data source is basically us telling Prisma which database we're going to connect to, is what we just spent time looking at. Now, the next is a model, and the model is what we're going to be using to define our database tables and their fields. So as an example here for this video, we're going to start off just building the simplest model that I can think of for a project. It's a model that I think every project has, which is the model for a user. So to define a model, you just write model, and then you give the name for the model or for the table. So we're going to call it user. Then you have to define the fields that this model is going to have. So let's think about what fields, at least let's start very basic. What is the most basic field that a user has to have? Well, in reality, especially if you're working with SQL databases, you should be having an ID in every table. So the most basic field is going to be an ID field. So in order to define an ID field in Prisma, I write the name ID. Then I put some space and I define what is the type of this field. And there's a variety of different Prisma types, but for an ID, it is an int. Then we have to define that this is a specific ID. So for IDs specifically, we can actually put this cool decorator called the @ID, which will just mark this field as the primary key for this table, so that every row needs a unique ID when we are creating this table. Now we can also add this other marker, which is a marker to tell Prisma to whenever we create a new row in this table, it is actually going to auto increment this field. So we can start the ID with 1, with 2, with 3, whatever we want, but let's imagine with 1. And if we add the decorator at default, and then we put auto increment, this will basically tell Prisma to automatically increase the number for every time we add a new row. So this is just the most basic example of how you would build an ID in every single table that you create. So you would be using this in every table that you make. Now this default decorator over here, even though we just used here to auto increment, it actually can be used in other fields as well. For example, what is a field that is also very crucial for a user? Well, the name field, right? The name is a thing that every user has to have. Now with name, we have to think of what the type is, and a type for name is string. Now, a name is not an ID, but if we wanted, which I don't think you should, we could put a default value to it as well. If we came over here and we put default, and we put, I don't know, Pedro, this will just make it such that this field in the table will always default to Pedro if nothing is added. You can use this for a lot of different things. For example, you can use this, it's very useful for when you're making a created at field, because then you can just pass you could, like, if I were to make here created at, I could make it into a datetime and then pass a default value as now. And that's another function that you can use in Prisma to get the current time. Now, we'll delete this. We don't want to also put a default value for Pedro. It was just as an example. Now, another field that we might want to be able to add is an email field. So an email would also be a string, but differently from name, an email would have to be unique. So we can add this unique property over here to it, which will basically prohibit us from adding two users with the same email. And just like that, we made the most basic model that we can think of. Now, we just wrote code for it, right? We didn't actually make it on our database. If you go here to the tables, we don't see any tables in our Neon database. So we can actually generate publicly our table here directly from Prisma by just creating the models, and Prisma will do the work for us. And to do that, we have to migrate our Prisma schema. So I'm going to open up our terminal over here, and in the same folder that I'm in, I'm going to run npx prisma migrate, and then I'm going to put dev and -- name, and I'm going to give it as init. Now, let me break down what this means. Well, the npx prisma will obviously get us to be able to execute Prisma commands. Then the migrate command is basically telling Prisma to apply the schema changes to our database. Then the dev over here is just to say to Prisma that this is all in development. If we want to actually push this in production, you'll see later we have a different command for that. And then we can give a name for this migration. So every time you make changes to your tables in your Postgres or whatever database you're using, it is good for you to keep track of all the different migrations that you did. So you give a name, and since this is the first time we're making any changes to our table, I'm going to call it init. So we do -- name and then the name of the migration. When I run this, it will take a bit, but if everything that we've done so far was set up correctly and the environment variables were correctly loaded from our .env file, we should see that the migration was executed perfectly. So first of all, let's see what happens here. It generated this migrations folder, which includes a record of all the migrations that you've made with your table. So all the changes you've made of your table, which you might not be thinking is that big of a deal, but when you're building a large scale project, this is important for record keeping. But most importantly, when you go to Neon and you refresh the page, you should now see the table that we just created, exactly how we defined it. So we see here a table with the ID field, the name field, and the email field. Not only that, but Prisma also gives to us a migrations table with a bunch of stuff that they set up themselves. So we don't even have to worry about keeping track of that. It's on the project, but it's also on our hosted database. So this is how we set up our first table using Prisma. Now, how do I actually access and make changes to this table using Prisma? Because like I explained in the beginning, Prisma is an ORM, right? It's supposed to make it easier for us to interact with this table and with our databases by using a connection with TypeScript or JavaScript. So the way we do that is we need to generate the code for that our client can access our schema. And to do that, here's the second important command that you need to know. The Prisma migrate was the first one that you need to definitely know. So that's when you make changes to your table. But here is what you need to know for how do you generate those changes and have access to it in your client. To do that, you run npx prisma generate. And when I run that, you should see that now we have generated the Prisma client. And whenever we want to access it, in our code, we will be able to. So let's try it. So we don't have actually any data right in our table. We could manually just add the records here and fake some data, but I want to actually create this thing which is known as a seed. Basically, we're going to populate our table with some fake data, some initial data just for us to test. And I'm going to make here a file in our Prisma folder called a seed.ts. Now, this is not that important of a topic, of a concept. It's just us adding some initial data to our table. And the name is seed because we're seeding the data, right? We're seeding the table by giving it data. So I'm going to make here an async function called seed, which we're going to call to actually implement and send that data. Now, in this function, we need to access Prisma. So I'm going to import at the top over here from at Prisma client, and I'm going to import the Prisma client class. So let's do Prisma client. Then I need to create an instance of this class. So I'm going to say const Prisma is equal to new Prisma client. Now, with this Prisma variable over here, we have access to altering and executing commands to our table. And it has full detail of how our schema is because we ran the generate function. So, for example, if I want to access and create data on the user table, which is the only table we have. But before we do this, we have to make one change. So in our schema.prism over here, we actually have to delete this line, the output line. We want to delete this and also delete the generated folder. I forgot to do this in the beginning, or else our type definitions won't work. So now that we made some changes to our schema, I actually want to run the npx prisma generate again. And now what we should see is that I can actually call our Prisma model by, first of all, saying await, because this is an asynchronous execution, then calling the Prisma client. And then when I click dot, you should see that we now have a list of our models, specifically the user model over here. When we click on that, we actually have a bunch of things that we can do with it. These are all functions that correspond to a SQL statement that you could then run in your actual table. But instead of doing that, we're going to do it directly using Prisma as the ORM. So in a seeding function, what we want to do is obviously create and populate our database with initial data just for testing. So we want to create data. So we want to add stuff to this table. So if you want to add stuff to a table, you can call the create function. And this function allows you to pass information about the data you want to add. But in our case over here, we want to add more than just one thing to the table. So I'm actually going to be calling the findMany function, which allows you to do the same thing, add some data to a table, but add multiple things to a table. So the way this works is very simple. You just pass an object over here with a data property, and it allows you to pass an array. And in this array, instead of passing data in the format that a SQL table might expect, we're going to actually pass it as a JavaScript or TypeScript object. So for example, if we look at our model, it's very simple, right? There are 3 fields, but 2 of the fields are very similar and 1 is very different. The ID field, we don't have to pass anything for it because it auto-generates and auto-increments, as you can see. So we only have to pass data for the name and for the email whilst following its type definition. So let's start with the name. I'm going to pass here name, which already has auto-generated types because, like I said, Prisma knows what the type is. And we're going to pass here, for example, the name Alice. Now we also have to pass an email. This email is going to be alice@example.com. Now let's add another user just to populate this. I'm going to copy this same format and we're going to add the second user. It's going to be Bob. And we're going to put bob@example.com. Now we have this seed function that when we call is going to hopefully execute the create command on Prisma and add 2 different entries to this table. So how do we call it? Well, we can call it down here by saying seed. That way we just call the table, the function. But it's also important that we disconnect the connection between our project with our Prisma client. So one thing we can do as well is after this is done, we can run this Prisma.disconnect. It's a way for us to prevent any leaks from happening due to us not closing the connection. Now, in order to run this seeding that we created over here, we have to go to our package.json and we're going to create a Prisma key inside of here. We're going to say Prisma. And we're going to add a key inside of the Prisma key called seed. Now in here, we're going to run the following command, tsnode, and then put the path towards our seed file. So it's going to be prisma/seed.ts, so that whenever we want to add and populate it with data, we can just run the seed command and it's going to generate and populate our table. And now if we want to test creating and adding this data into our table, we can just run npx prisma db and seed, and now we'll have that command actually added. You'll see it will say running seed command, the seed command has been executed, which means that if we have successfully created our seeding function correctly, when we refresh this, we should see the data in our table. And that's exactly what we do. So without running any SQL commands, without going to the SQL editor over here and running stuff, we were able to add data to our table with simple JavaScript. But let's see what would happen if we broke one of the rules that we implemented with the schema Prisma. So for example, if I wanted to add 2 more users, right? I wanted to add Pedro and I wanted to add Caroline. Now I'll put here Pedro at example. And for some reason, Caroline also wants to put the email Pedro at example.com. When I run this command over here, let's see what would happen. I'm going to put npx Prisma and yeah, it broke. Why did it break? Technically, it didn't break. It's just that it failed to execute what we wanted it to, and we're not handling errors here. We could, and then it wouldn't actually break. It would just deal with the error. But it broke one of the rules that we set on our Prisma schema, which is that the email field needs to be unique. So that's one of the cool things. You can define stuff like that very easily by just putting here the unique decorator, and it will mark that field as unique. And I wanted to show you guys an example of where that would fail. So let's just actually add more people into our table. I'm gonna fix that and let's run it again. And you'll see that now it's very easy for us to populate our table. We just run that command and we can see the data here. Perfect. Now, how would we make a simple API that deals with our Prisma tables? So I'm going to actually come here to our index.js that comes with this starter project. And we have this server that is running, right? And on the server, we have this app that we can use to generate an API. So we'll start with the most basic API endpoint that we might want to implement. So I'm not expecting that you know Express, even though I do think for learning Prisma in TypeScript and JavaScript, you should know Express, at least have an idea of how it looks like and how it works. But the basics of this is that we are making endpoints, right? And for the server that we're running on the localhost 4000, we want to create an endpoint that is going to get all of the users in our table. And how are we going to use Prisma to do that? Well, I'm going to make here a get endpoint. I'm going to set the route to be /users. I'm going to make an async function that is going to run over here. We don't need the request. We just need the response. And inside of here, to get the users, I'm going to be using the Prisma client that we created. So I'm going to come over here. I'm going to say import Prisma client from Prisma client. I'm going to create an instance of Prisma just like we did on the seeding file. So I'm going to say const Prisma is equal to new Prisma client. And in here, I want to create a variable called users. And through the Prisma client, I want to await the Prisma.user. And instead of creating items, I want to find items on my table. Now, Prisma provides us with 5 different find functions, and they're all unique in their own way. So find first, it's pretty interesting. If we just use this and I return here, for example, the list of users as a JSON, we can see that if I actually went here and I went to the localhost 4000. Oh, I just realized my server stopped running. Let me run it again. So if we went to the localhost 4000, then we went to /users. We just made an API endpoint to the /users route, and it returned one entry from our table. But as the name might imply, the find first function just returns the first item in the table, which is Alice. So that's what that function does. Now let's go into the other one. The second one is find first or throw. And you'll notice that in Prisma, this is a common pattern. The idea here is that there's 2 different scenarios, right? There's the scenario in which you might just want to literally look for some data, like the first item, like we did before. And if there was no first item, then, and we were using the find first, if the table was empty and this returned nothing, it wouldn't error. It would actually just return null. So it wouldn't see it as an actual error. because it's not expecting anything to be in the table. It's okay if no results exist. But on Prisma, you can specify that you actually want to throw an error if nothing is found. So let's see this as an example. This works on every other find function. To test this, I'm going to go over here and I'm going to delete everything in our table. So let's delete everything. And because I'm using the find first function over here, if I refresh this now, it should return no. But what happens if I say find first or throw? You'll see that now if I refresh this, all of a sudden, it doesn't just return no, it breaks my app. Obviously, we're not handling it here, but if we were, we'd probably put a try catch and then actually return a good like front-end facing error message to the user. So this is the difference in all of the versions of throw, and I think that's important for you to know. Now, let's go back to find, and let's actually populate our table again. So what I'm going to do is I'm going to go back to here, and I'm going to just seed our table a little bit more, and we should see Alice. Actually, we should see Pedro and Caroline appearing here, I believe. Yeah, perfect. Now we can get the users back. But what other find functions we can use? Well, the user's route is important because it actually can return the entire table. So when we put here findMany and we don't specify anything, we just keep the arguments of this function empty, it will return the entire table. As you can see, we only have 2 users, but it will return the entire table. Now, if I want to find an entry for a specific reason, for example, I wanted to find one user, I can use the findUnique function. And this findUnique function allows us to specify a condition inside of this parentheses over here that will return back a user that is unique in the table. Now, what can we pass here? What conditions can we execute? Well, you can compare any of the fields that are tagged as unique plus the ID. So for example, I can find a user based on their ID by coming to the findUnique over here, opening and closing curly braces, putting a where condition, and then saying that I want to find a unique user where the ID is equal to, I don't know, 6, right? I know that that's the first user, Pedro. So if I do this, now when I return this, we get Pedro. If I change this to 7, we get back the user with ID 7, right? Now, I could also come here and find a user based on their email because email is a unique field. So I could say here, find where email is equal to pedro@example.com, and we'll refresh this and you will find Pedro. However, I cannot do this. I cannot say name and then look for Pedro. You see, it doesn't even allow me to because Pedro is not a unique field. So that's the specific thing with findUnique. It is great for finding users based on their ID or any other unique fields. Now, this where conditioning over here is super crucial for Prisma because it allows you to write complex queries using JavaScript. So for example, let's actually make some changes to our table. I'm going to come here to the Prisma schema and let's add a couple other fields. Let's put age. Age should be an int and no other things we need to, like there's no other thing we need to specify with it, right? Now I also want to add an is married field, which just says true or false for either the user is married or not. And I'll put it as a Boolean. Now I'll also make a nationality field, which will be a string. Now we added those 3 because it will just make it such that we have more room for us to be able to write complex queries. Now if I want to make those changes go through, I need to first migrate. So let's remember, what is the migrate command? Well, we need to run npx prisma. We put migrate. We specify that this is for a dev environment, and we give it a name. Now I'm just gonna say edit new fields or something like that, and I'm gonna run, and we should see that when this is done executed and we go to the public database, we should see the new fields. But here's the thing, we can't actually execute this because we made all of them into required fields. Now, how do I know this are all required fields? Well, whenever you define a field in your schema and you don't put a question mark after the type definition, it is a required field, which we just defined age and is married as and nationality as required fields, which means that the users that are already there could not be part of the table. So we need to either delete all of the users from our table or make these fields optional like this. But I don't want to make them optional. I actually have that seeding function, so it's pretty simple for me to just add them again. So I'm going to delete the record over here. We are going to make the migration. I do need to update the seed function to include age and so on, but that's beyond the fact. We're going to add here the migration, and I'll be back when it's done. So now it's done. After every migration, I need to generate the types, right, for the Prisma client. So I'm going to run npx Prisma generate, and we should see that not only now our table looks a bit different because it includes all the new fields, right? It includes the age, the is married, and the nationality, but we should be able to access those in our seed function. So I'll come back here. You see, it doesn't even, it gives us red squiggly lines to notify us that we're missing a couple fields. So I'm going to add a bunch of actual data here. I'm going to add more than just 2, and I'll be back in a second. So I generated here some more fake data. I'm just going to copy and paste it over here. And you see each of them, it's 10 users. Each of them has actual data. I just used ChatGPT to generate this, but we're going to run the command so that we can actually see the changes in our table. So I'm going to run npx Prisma db seed, and we should see that if it's done, the seed command has been executed, and we should see 10 users here. Perfect. Now, why did I add 10 users? Well, now we can learn how to apply some conditions that are a little bit more complex when we are requesting data. So like we've learned, we can run the findMany command, and this will look for multiple items inside of our schema, inside of our table that match a certain condition. So if I were to run this, then we would only get one user, which is Pedro, right? Because that's the only user with the name Pedro. But with this where over here, especially when it's not a unique find that we are running, we can actually add a lot of things. So let's start with an easier condition that can return multiple users. So let's imagine this. I want to return only users that are married, right? That will return multiple users because a lot of them are actually married. So to do that, it's easy. I just come here, I change the field to is married, and I put that I only want to find many users which is married is equal to true. If I do that, you see now I get every single user that matches that condition. If I were to switch that to false, I would get the exact same, the exact opposite of that. So now, what if we merge two conditions at once? Well, what if instead of just getting users that are married, I also want to get users that are married, for example, James over here, but the age is greater than 35? Because then we get James, but we don't get Noah, right? Because actually, let's make 30 the age. So greater than 30, Noah is 30, but that's not greater than 30. So we won't get Noah, but we will get James. So to do that, I first put the condition of is married equal to true. And then I can put the condition that age is, and then because I want to apply a comparison to this specific field, I'm not going to put a direct value here, because if I did this, then it will just return users whose age is 30, which in this case is just Noah, right? One user. We actually want to apply an additional condition to this specific field. And to do that, you actually apply an object to it. And in here, you have a bunch of comparisons that you can apply. For example, you have less than, that's what LT means, less than or equal to, that's what LTE means, and also GT, which is greater than, and GTE, which is greater than or equal. In our case here, we want to get users that are married and that are greater than or equal to, or are greater than 30, that the age is greater than 30. So in this case, like I said, we will get, for example, Liam, we're going to get James, but we won't get Noah. So if that's the case, let's see what happens. And yeah, perfect. We got James, we got Liam, we got Lucas, another person, but we didn't get Noah. So this is an example of a simple but a little bit more complex query that you can make using Prisma. Now, I want to do something a little bit different. I want to apply an OR condition to this query. So for example, what if I want to get people that are married, or so like everyone who's married, or people who are Brazilian. That's a case, right? So I don't want to just get people who are Brazilian and are married. I want to get people that are married or they are Brazilian. To do that, what I can do is, instead of just applying the is married like this, I can actually use an or condition. And in here, I pass an array. And what this array will do is it will detect every condition that we pass to this array will be part of this or. So we will add the items for each condition to the results that are returned. So for example, if we put or and then we just pass nationality is equal to Brazilian, then we obviously just get back one person, right? Pedro, who is Brazilian. Now Pedro is not greater than, actually Pedro is greater than or equal to 28. Let me get someone who is, let's make 29 and above. So now the or condition here is that we get age, and that age is someone who is greater than or equal to 30. So Pedro is not including that, but Pedro will still be returned here because the condition is that either the person is a Brazilian, which Pedro is, or they're above 30, which all of this, above or equal to 30, which all of these people are. So this is how you kind of apply union between this condition and this condition. Now you could also do this, which is apply an end. And when you apply an end, this would not return anything because there's no user who is Brazilian but has an age above 30. But if I change it to 25, obviously it will return Pedro because Pedro's age is 25 in this project. So this is the opposite of doing an or. It's having an intersection between two different conditions. Now, one cool thing you can do as well is applying some negation. For example, I could say that I want people who are not Brazilian. So why would I do that? Well, I'm going to remove this end over here. I just want to apply a condition that a person is not a Brazilian. So to do that, I can just turn this into an object and apply the not property to it. And then what I'm doing here is I'm getting all users where nationality is not this value, which I believe will be everyone but Pedro. So you see here, it's everyone but Pedro. We have every other nationality but that one. So that's how negation works. To build off of this example, we also can actually detect if a field is part of a set of fields or a set of values that we want to search for. So for example, if I only want to get all the users that are either German, Portuguese, or Irish, right? I could come over here and actually do this. I could do this. Put an or over here, pass an array, and then put nationality is equal to Irish. And then put a comma and then add again. Nationality is equal to German, right? And then again, nationality is equal to Portuguese. If I do this, you might expect that it will return every user that is either one of those nationalities. But this seems kind of redundant, right? We're checking for the nationality 3 times. What you could do instead is you could remove this or, you can remove all of this, and you can use this really cool property that you can apply to fields. I come over here, I say I want nationality to be, and then I say that I want to get users whose nationality are in a set of nationalities that I want to search for. And then here I just pass the Irish, the German, the Portuguese. And now what Prisma is going to do is it's going to generate a SQL query that is going to look for every nationality that is part of this array. And you see that I'm going to get the exact same return back or a result back because it's a way easier way for you to write that query, but it still works. So this is the mini crash course I had for different queries that you can make using Prisma. I think that understanding all of the different features and properties that you can apply to your queries make your life when using Prisma a lot easier. Now, I'm going to take this course into a different direction now, where we're going to first learn, obviously, the 2 other CRUD operations that you can apply to any API, which is updating and deleting. We've learned how to create and we've learned how to get data, but we'll quickly gloss over updating and deleting users. And then I'm going to teach you guys how to apply Prisma into a real world Next.js project. So in order to learn how to update a user first, it's actually pretty simple. The way you do this is we're going to come over here and we're going to put a put request just to make the same request over here, but for when you are updating a user, right? That's what put usually means. Then we're going to put an async property over here. I'm actually going to copy this whole thing just to make it easier. And we're going to change this to put. And when you want to update a user or update a value in your table using Prisma, you use the update function. So use the update function. And as you can see, you can apply this update into 3 different ways. You can update one single item, you can update many items, and you can also update many items and also return the items that you updated. That's what those 3 mean. But we're going to use the update function. And just for simplicity reasons, I'm going to change this to updated user so we get it back. But I'm also going to update one specific user. I want to update Pedro. That's the user I want to update. So the user that I created for myself, I want to change their age to 35 or something. So when you're running the update function, you have to specify which user you are updating. So the way that works is you go to your schema, right? And you look at this model. We can only detect a specific user by 2 different fields. The unique field, so the ID or the email. Because if I try to update a user named Pedro, there might be 2 users who are named Pedro, and then that won't work. So you have to pass a specific unique value in your table to this where property. So we're going to update where, and then here I'm going to ask for the email. So I'm going to put here that where email is equal to, and then let me look at what email I put for Pedro. Pedro@example.com. So we're going to update the user who has an email equal to Pedro@example.com. And then what I need to do here is I need to update the data, right? I need to pass what data do I want to update. So I'm going to pass here data, and I can specify which parts of the user I want to change. Whichever parts I don't specify will remain the same. So in our case, I just want to increase Pedro's age to 35. So I can pass here age and put it as 35, and that's going to update. If I want to update multiple parts of it, I can actually update, for example, the is married to true, and that will update it as well. You don't have to pass every new part of this user because some of the stuff will remain the same. Now, I need to run this endpoint. So to do that, I'm going to be using just normal curling. You can use something else, like you can use Postman or Insomnia or something like that. I'm just going to curl the URL of our API endpoint and make it into a put request. Obviously, we can't go here like we've been doing because this generates a GET request. We want to make a put request, so we have to actually curl it. And when we do this, you see we get back the same user, but now the age is 35 and is married is equal to true. Now, the way we know that this worked is we obviously go to our table and we refresh this, and we can see that these values changed. Perfect. Now, let's do the exact same thing before deleting a user. I'm going to be honest, deleting is always easier than updating because deleting is simple to understand. We want to delete a user where a specific unique ID is being passed. So I don't want to pass any data because that makes no sense, right? We just need to pass a where condition. That's the only thing we need. And this function is the delete function. Again, similar to the update, there's a delete many, but we're going to use delete here. And what I want to do is I want to delete the user where the email is equal to, and then let's delete someone random. I'm going to delete Liam. So delete where email is equal to Liam. I'm going to change this to deleted user, and I'll pass this here. Now, let's open this up and let's run a delete request instead of a put request. So I'm going to curl for the delete endpoint, and we should get back Liam, but the way we check this is Liam shouldn't be here when we refresh this. And yes, it worked. But the cool thing about deleting is that when you pass a delete many, you don't have to pass a specific unique ID for it because now you can actually pass a condition, right? I can delete every user who has let me see something that is, so every user that is above 30. So in this case, it will be Pedro, it will be Noah, and it will be James and Luca. So it will be a lot of people. So I could do that. The way I do that is because now when I'm deleting many users, there's not a specific unique user I want to delete, so I don't have to pass a specific unique value to it. So I'll just pass here, I want to delete a user where age, and then obviously I have to pass a property here, is greater than 30. And you'll see that when I run this now, actually we should update this to deleted users, and this is deleted users. And when I run this, we should get back a count. Now the reason why we didn't get the whole amount is because when we are deleting this, it's better to just return a count so we know how many users were deleted. And you can use this later when you're like, if you have like a list in your UI and you're clicking the users to delete, you can then pop up a notification or a toast saying deleted, and then you have the count to say how many users you deleted. So now we can refresh this, and long and behold, you see all of those users are deleted, and everyone with age greater than 30 is now gone. So this is the basics of implementing a simple CRUD and the basics of the Prisma syntax and how to implement it in a project. Now we're going to be actually building a project with Prisma. This is super exciting. If you want to check out the code, it will be in the description together with the code for this starter package and the point that we're in right now. So go ahead and click the link in the description. You will see the video info kit, and it will have everything there. So let's get into building the project. Okay, everyone. So now let's start building the project. Like I mentioned in the beginning of the video, we're going to be building a job posting website, and it's going to be Next.js using Next.js 15. It's going to have authentication, and it's also going to be entirely using Prisma. So in order to build this project, I have a starter version of the project, which you can get from the description below. So if you go to the description, you click the link, you'll see the final code for this video, but also find the starter code for this project. So go ahead, click that link. It's basically just a normal Next.js app I created using create next app. The only difference is there's going to be some CSS in here that I added to the global.css. Also the favicon, I made an icon for the website, and I put that same logo into the public so that we can use it on the website as well. So that's all that you have to keep in mind. Also, we have this package.json, and on this package.json, it contains all the dependencies and dev dependencies we're going to be using on this project. I already have them here with their respective versions. When you download or when you clone this package, you just go ahead and run npm or yarn, whichever package manager you're using. You run npm install, and it's going to install all of those and create the node modules folder, which is already over here, but it will add those packages to that folder. So let me go over real quick what are the dependencies, libraries, and stuff that we're going to be using for this video. So for the project, we're obviously going to be using a Prisma. So we have here Prisma client. We're also going to be using Prisma extension accelerate, which is just going to help us set up Prisma in our Next.js app. We're also going to be using NextAuth for authentication. I'm going to be using version 5 for that. So if you want to install the package from scratch, you'll have to make sure to specify that you want to use version 5 because it's still in beta. But in order to use Prisma and connect it to our auth provider, we're going to be installing this auth Prisma adapter that connects a Prisma database table with NextAuth or auth.js as it's now known. So we definitely need that. And also we're going to be using datefns just for some UI dates that we're going to be creating on the project. And I think that's pretty much it. All the other ones just come with a Next.js project. So let's close this off and let's run the project. I'm going to run npm run dev, and we should see that when I go into our Google Chrome over here and I run localhost 3000, we should be able to see our project running. Perfect. Now, what I want to do is I want to take a look at our tables here. I already made some small changes to them since the last time we talked about, but I'll just tell you guys what you have to do. Just delete all of the tables that were there. The user table that we created, just delete that. You delete it by clicking on this button and clicking on drop, and then you just delete it. Also, the Prisma migrations folder, we're going to delete this as well. The reason for that is because we're going to generate it again through this project. We're going to use the same Neon database we used for the the other part of the video for this project, so I would delete that. Now we have to use Prisma to create our Prisma model and set up Prisma on our project. So we've done this before. We already have Prisma installed. So I'm going to run npx prisma init. And what that will do, as you remember, is it will create a .env file, which is going to help us input our database URL, which again, we can get it from the project that we're just coding on. I already have it set, next to me over here, so I'll just paste it. This is the URL for the table that we have on Neon. But also we come with a Prisma folder, and inside of it, there's a Prisma schema. Now on the schema, previously we didn't have an output, but now I want to keep this output. You see, it's outputting to the app generated Prisma. This will make it such that we're going to have a folder on our app folder over here, which is going to be called generated. And inside of it, it will contain all the generated types created by Prisma client inside of it. So we're going to keep this. We don't want to deal with this like we did on the previous project. We're going to keep it this way. And I think the rest should be fine. Provider should be Postgres and so on. Now, I want to talk to you guys about something. Since we're using NextAuth for this, which again, it's a authentication provider for our Next.js project, we need to set up some of the models that they give to us that are related to a user's authentication state. So they have support for Prisma, and they provide to you actual models that you will then have in your database automatically that keep information about a user session, a user's account, and so on. So you can go to the auth.js NextAuth website and copy the models that they provide for us, that they specify for us. But I'm actually just gonna copy and paste it here because this is what they give to us. I didn't write this. So the first thing they give to us is a model for an account. This is just an account that a user has when they create an account and authenticate on their website. It includes stuff like their ID, their type, the provider that they used, which we're going to have to use GitHub for this video. The user is going to be able to log in with GitHub, and stuff like the refresh token, access token, and so on. So this is what the account type looks like. We're then going to have the session type. This is the session model. It will have a table that will contain all of the different users and their sessions, including their session tokens and when they expire. So this is really cool because you'll be able to see the sessions for each user. Finally, we're going to have a verification token model, which, like the name implies, it's for authentication purposes, and it will include verification token information. So we have those three models. We don't have to worry too much about them. Just know that they're necessary for when we create the authentication for our project. And now we can actually start creating the tables and models we're going to be using in this video. And starting with the most basic one, which, if you think about it, is similar to what we have used in the previous part of this tutorial. We're going to be using and creating a user. So a user is going to be a table. It's going to be a model that it differs a bit from the model of account or session and so on, because this over here keeps information about an account's or a user's auth state. A user, on the other hand, is going to keep track of some other information about the user. For example, their email, their name, if their email is verified, any profile picture, and also it will include information about the user's accounts, the user's sessions, and so on. So to do that, we're going to come down here and we're going to create a model called user. Now on user, we're going to have an ID. The ID is going to be a string, and it's going to be @ID. And as you might remember, it will be at default. And instead of doing auto increment like we did before, we're actually going to be using a different function. It's going to be called CUID, and CUID will just generate a random ID, which is a string of like a bunch of numbers. So this is how you generate that ID. Now, after this, we're going to be wanting a name. So each user will have a name, and it will be optional just by default. Then we're going to have an email, which will also be a string that is optional, but an email has to be unique. Then we're going to have an email verified, and this is optional. You don't have to put this, but this is just the time in which they verify their email. For our project, we're going to be using GitHub, so this isn't really applicable, but I usually, when I create a user, I have this in case I make sure that they are allowed to authenticate using email and password. Then we're going to have an image, and an image is just a profile picture. It will be a string because it's going to be a link to their GitHub profile picture. Then we're going to have accounts. Now, this is where we introduce a new topic in Prisma. And it's a topic that isn't Prisma specific, it's SQL specific, and it's about relations. So a user has an account by default, right? So when you create a user, you authenticate that user, you authorize the user to get into the website, and an account, a session, a verification token is created. So what we need here is we need to establish the fact that a user can have multiple accounts. So we're going to set the type of accounts here to be account and array. Now, we're also going to do the exact same thing with sessions. So we're going to say sessions and session array. Now you see I'm getting red squiggly line here, and it's because when we associate type a model with another model like we're doing here, we have to establish the relationship by coming to the other two models like the account and the session, and establishing that relationship by defining that other model here. So for example, we associated the account model with the user model. So on the account model, I have to define a user, which has a user type, and I have to establish that relationship between them. So for example, what relates a user to the account? So let's think about it. What part of the account model can help us identify when we are looking for a user that owns that account? Well, a user has a user ID, and guess what? The account also has a user ID. So what we can do is we can say that this user relation here, so we use the relation tag, and we say it's compared, it's associated based on the fields, and here we put the field in the account model that we will compare to the user model, and in this case is the user ID. So we say the field is this, and the reference on the other model is the ID. So it's this. This should be equal to this, and that's how we establish a relationship. We can also specify on delete. So what is on delete? It means if one of the two, an account or a user, is deleted, what happens to the corresponding account or user in the other table, right? If a user is deleted in the user table, what happens to the user with that user ID in the account table? So we put cascade, meaning that it will delete on both tables. So this is how we establish that relationship. And we're going to do the exact same thing on the session over here. We're going to establish the same relationship. And since we also have a user ID here, it will be the exact same thing. So perfect. Now we have learned, first of all, associations and relations, and we have established that relation. And this is pretty much what a user will look like. Now let's create the auto models that we need on this project. So the main core of the project is that we are a job posting website. So what do we need in a job posting website? We need a job. So we have to create a model that is going to represent what a job looks like. So I'm going to create here a model, and we're going to call it job. In here, we want to have the same thing as we did for user, an ID, same, like it acts the same way. Then for a job, we need a title, which is going to be a string. We also need a company name, which is going to be a string. We need a location, like a city/country that we need, and it will be a string. We need a type. Now a type is going to be like, is the job part-time? Is the job full-time? Is the job a contract? So that will also be a string. Then we need a description of the job. So when an employer posts a job, they need to write a long description. So we're going to specify that this is actually going to be a db.text, just like this. And then we're going to ask for a salary. A salary is going to be a string, but it's also optional. I think like jobs might sometimes don't put the salary range, right? Or the salary as a whole. So we're going to make that optional. Then we want to get some stuff that is important for when a job is posted. So for example, when was this job posted? So posted at. Now that's a date. So I'm going to put here a date time type, and we're going to default it to now. And what that does is it basically creates the current, whenever we add a new job, this is going to be automatically filled in by the current moment so that we actually have information of when the job was posted. We're also going to have a posted by. But then let's think about it. If a user can post a job, right? Then this posted by type field over here is going to have a type of user, which now gives us an error because we don't have a relation between a user and the job. So let's think about it. Is it that a job has multiple users, or is it that a user can have multiple jobs? Is the association such that user is the one model that can relate to many jobs, or is it that one job can relate to many users? Well, if you think about it, yes, a job can relate to many users, but when we create our website, we want to keep track of all the jobs that a user have applied to. So the association is going to be such that when a user creates an account, we're going to keep track of all the jobs that they have applied to. So we're going to keep track of all the jobs. So I'm going to create here jobs, and I'm going to create a job type that it's an array. Now to do that, I'm going to establish that relationship over here. So I'm going to say @relation. And we're going to give a name to this relation, which is a bit different from what we did over here. So the name of this relation is going to be posted by or posted jobs. And I just want to know who posted this job, which user posted it. So we're going to set the fields to be posted by ID. And we don't have that field yet, so we have to create it over here. That will be a string, because when we post a job, we're going to pass the user ID. When we create a job, we'll pass the user ID, but we don't have to pass all of the user's information. It's going to be auto-generated based on that ID. So then we have to pass the references, and the references will be the ID type on the user model. This means that now we have successfully established a relationship. But wait a minute, it's still giving us red squiggly line, even though we did exactly what we did with this with the session and account on the user. While the session and the account relations don't have a specific name to it. Remember, we didn't put this name over here. So when you put a name to it, you have to also establish the relationship or specify the relationship on the other side. Perfect. Now we have successfully established the model for a job. Now the last model we want to create is an application. So I'm going to say model application. And for the application, again, we're going to have an ID, which is going to be a string. We're then going to have a job ID, which is also going to be a string. We're going to have a user ID, meaning which user applied for this job, which is going to be a string. And we're going to have a status. Now, what is a status? A status is going to be basically what is the status of this application. Is it pending? Is it accepted? Is it rejected? Is the user reviewing? But this website won't be extremely complex in the sense that it's like the user will, the employer will actually go ahead and establish a contract and all that kind of stuff. We're going to keep it simple because the whole point of this video is not to teach you guys how to build this project, it's to teach you guys Prisma. So we're going to keep it as simple as possible. We're going to default it to pending. So we're going to default it to pending, and we're going to keep it like that. All applications that are published are going to be pending. But if you want to expand on this project, you could then add the ability to change it to reviewing, accepted, and rejected, or so on. So you can do that as an extension to this project. Then we want to have an applied at, and this is going to be a date time, and we're going to default it to now, similar to what we did above. So default now. Now, let's think about what an application needs. So an application connects two different models. It needs a model of a user, and it needs a model of a job, because it's the bridge in between a user getting a job is the user making that application. So in an application, we need to keep track of information about a specific job and a specific user. So we'll have to establish relations for both of those models. Let's start with user. So I'm going to say user over here of type user, and I'm going to say it has a relation in which the field's user ID references the field ID, right? Because we created the user ID field over here. We'll do the exact same thing for the job and the job ID. So we'll say job and job, and we'll change this to job ID, and the reference here should still be ID. Now it still writes squiggly lines again because we have to establish them on both the user and the job type. So over here for the job type, I'm gonna say applications and then application array. And for the user, I'm gonna say applications and then application array. Perfect. Now, one thing that I wanna do is I want to enforce the fact that a user can only have an application to a job once, meaning a user can't apply to the same job multiple times. That's an important factor to consider. And that relates perfectly to an interesting thing you can do in Prisma, which you've already seen up here, but I didn't explain because I was going to get to it. You can establish a unique enforcement to a relation. So for example, in here, he's saying that a verification token can only exist if the combination of the identifier and the token are unique. This is known as a composite unique constraint on this model. So in this case over here, we have to implement a composite unique constraint on the application model because it will ensure that each combination of a job ID and a user ID is unique in the database. And to do that, you come down here, you apply a double at unique, and you pass an array of the two of reference values. So we want to make a unique combination of a job ID and a user ID so that a user can't apply to the same job twice. And finally, we're pretty much done with all of our Prisma code for this project. We have created 3 different models ourselves and used the models that Auth.js or NextAuth, whatever you want to call it, are going to use to let our users authenticate. Now, what we have to do is we have to migrate this DB into our tables. So I'm going to say here, npx prisma migrate dev and then -- name, and I'm going to give it a name. It's going to be init so that we initiate this project. I'm going to press enter. It's going to load the .env variable from our .env file. And if everything goes right, it's a big creation. We're going to be able to see those tables in our schema. So let's go back over here and let's refresh this. And all of a sudden, boom, you see all of the tables. Now, one thing I need to let you guys know in case you run into this, if you didn't delete the Prisma migrations folder table before, and you still had leftover migrations from the previous project that we've built, you might want to run this command over here, which is going to allow you to reset the migration table. So if you run into issues where it's not allowing you to because you have migrations already, you run that and it's going to work. So we have successfully created here our tables. So let's start building the code for this project so that we can use these models. And before we do that, let me just actually generate the types, right? So I'm going to run npx prisma generate. It's going to generate, first of all, a generated folder on our app because that's how we established over here where the types are going to be at. And when we create a Prisma client, it's going to use those types. Perfect. So I'm going to close this and let's get started. So let's start with the navbar. So over here on our layout.tsx, I want to make a navbar. And the reason why I want to make it first is just because we're going to use that to be able to allow a user to sign in into their accounts. So in our layout.tsx, I want to wrap this the children around with a main tag. And I'm going to put an entire project inside of this main. We're going to have here the navbar component that I'm going to create. I haven't created it yet. And I'm also going to apply some minor styling to this main tag. So we're going to make it into a container. We're going to set mx to be auto, px to be equal to 4, and py to be equal to 8. Now, I'm not going to be writing styles in this tutorial in the sense that I have the styles done for the project, but this isn't at all the purpose of the video, and I think it will make the video very bloated if I explain every class name and every style that I make. I have tutorials on Tailwind CSS if you want to learn it, but I will copy and paste the styles that I've already written and show you guys doing that. So if you want to get the styles, go ahead and click the link in the description or just copy from the screen whenever I make them. So perfect. We have here our class. I'm also going to add here a div that is going to wrap around our navbar and our main. And on this div, I'm going to add a very basic class name, which is going to set a minimum height of the page to be the screen size. And it's also going to set the color of our background of our website to be gray 50. So now we have to create this navbar component. So we're going to go back here to our project, and I want to make a components folder. So I'm going to make that components folder here outside of the app. We're going to make components, and in here I want to make the navbar.tsx component. Now the navbar, it is going to be very simple because there's only going to be like 3 links or so. We're going to make here a function called navbar, and inside of it, we want to return some UI. So I'm going to return here a nav tag. Inside of it, I'm going to add another div and another div. So 2 divs, one inside of each other. Then in this second div, we're going to put the first part of the website. And the first part of the website, it is going to be, if you remember in the intro, there's like a logo with the name of the website over here, and then there's the links and the sign in button over here. So what we're doing here first is the left side of the page. So I'm going to add another div, and on here we're going to have a link, which is a next.js component, and we're going to put an image with the logo. So let's put the image over here. It's actually a component. So image, I need to import that. So import image from next image, and the image component is going to have a source, and the source is going to be the logo.png file that I've already added to the starter of this project. We're also going to apply an alt to this image because you always should for accessibility reasons. I'm going to say job board logo. I'm going to set just a minor width of 40, a height of 40, and that should be good to go. Now on this link, we want to put a path to where you go when you click the logo. I'm going to take the user to the home page whenever they click the logo. And I also want to put a span right next to the image, which is just going to write the name of the website, which is very generic. I'm just going to call it job board. Now I'm giving an error over here just because I haven't imported the navbar component, so we'll import it. And we should see that appearing on the top left. Now, on our navbar, we have finished the left part of the navbar. Let's start building the right part of the navbar. So on this div over here, we want to escape out of it, and we're going to make another div. This other div is going to contain a link to the browse jobs page. So the jobs page, we're going to make an href, which is going to take us to the /jobs page, which we haven't made it yet, but we're going to make it. And also we want to make a page for a user to be able to post a job and also see their application, so a dashboard. So we're going to have here a post a job link and a dashboard link. So the links for that is going to be jobs/post, and this one is going to be just /dashboard. Now we should see them over here. Obviously the UI is very unpredictable, but we're gonna add the styling soon, so don't worry about it. But we have now those links. We also want to add a sign-in button. So we're going to create here what is going to be actually a link. It's not going to be a button. We're going to say sign in, and we're going to put an href to the following link /auth/sign in. And it should appear over here as well. Now I want to copy and paste all of the class names for the styling of this navbar so that we can actually see a cool looking navbar appearing. Perfect. I just added here the styling. You can copy all the class names. I'm gonna just roll over a little bit slowly so you guys can see. But at the end of the day, you can just get all of this code in the description. And this is how our navbar looks now. It looks a lot better. You can navigate between the different routes. Obviously, a lot of those routes don't have any pages in them, but we're going to create them. So now let's close this off and close the navbar. We want to start building the sign-in page for our website. So that page is going to exist inside of our app. It's going to be a route. And we're going to create it. We're going to call it auth over here. So we're going to create an auth folder, and the auth folder is going to have a sign in folder, because if you remember, not singing or whatever that is, it's sign in. If you remember, on the navbar, we navigate to /auth/sign-in. So that's how we make that route. Then I want to make a page.tsx inside of here. And then in here, we want to export default function and call it sign in page. Now on this page, we want to return a div, and inside of it, we'll put another div, and again, another div. Now on this third div over here, we're going to have the top part of this auth page. We're going to have a little h2 tag just saying, welcome to the job board, or whatever I call this website. And then below this, I'm going to have a little p tag that will let us know that you need to sign in to post or apply for opportunities. So we'll say sign in to post jobs or apply for opportunities. And then below this, we can get out of this div. We want to create another div with the actual sign-in form. And in this case, our sign-in form is just going to be a button to sign in with GitHub. Of course, you can add other providers if you want to. You can check out the auth.js documentation for adding Google if you want to. It's extremely similar to what we will be doing for GitHub, but I just want to keep it simple, so we're going to have GitHub for this project. So to do that, I'm going to have a button, which is going to be the sign in with GitHub button. So in this button, we want to first have an SVG with the GitHub logo. So to do that, I have here the SVG generated. This is how it's going to look like. Let me go to the sign in page so you guys see it. Yeah, it's hard to see, but you can kind of see it over here, right? So yeah, that's the SVG for the GitHub logo. And then I want to add a sign in, a span that is going to say continue with GitHub. Perfect. Then just to make it a little bit cool and more authentic, I want to add this little div over here at the bottom, which websites usually have. It's saying something like, by signing in, you agree to our, and then I'm going to put a link to our terms of service, but we don't actually have any terms of service. So I'm just going to make an A tag instead of a link, and we're going to say terms of service. And I'm actually going to put this below here. And then I'm going to put end, and then I'll put another link to our privacy policy, or whatever sounds fancy. So terms of service are privacy policy, and it appears like this. Perfect. Now let me apply the styling, because you guys barely can see anything. So I'm going to be back in a second when I added all of the class names. And just like that, I added all of the class names needed for this page. You can see I'll scroll down a little bit slowly. I can also get over here so you guys can see everything. Really, guys, just check the CSS in the description. You don't need to copy everything manually. But now this is what it built. It built this little simple card in the middle of the screen, and it has the GitHub button, and it has those other privacy and terms of service policies as well. Now, what happens when I click on this button? Absolutely nothing. And that's exactly what we want to change. We want to start implementing the ability for a user to be able to sign in and authenticate with GitHub. And to do that, we're going to be having to create some stuff related to NextAuth. So like I said, we have installed over here a couple packages related to NextAuth. First, we installed the NextAuth package, and remember, it's in version 5, which is in beta. And we also installed auth/privacy Prisma adapter. That's going to be crucial for us. So when we are going to set up authentication using auth.js, we need to first create an auth.ts file at the root of our project, not inside of the app folder. Inside of this file, we're going to set up the entire infrastructure for our authentication. So I'm going to say here, import next auth from next auth. Then I'm going to say import GitHub. And this is actually something that comes from next auth. So we'll say next auth / providers / GitHub. And then down here, we want to import the Prisma adapter from auth / Prisma adapter. Now, to make this work, we need to have access to the Prisma client. And to make Prisma work in Next.js, especially with TypeScript, there's a thing that you always have to do. We're going to create a lib folder in our root of our project. So I'm going to create here lib. And inside of here, I'm going to make a prisma.ts file. Now in this file, I'm going to paste this code. Now this code over here is the code given to us by Prisma to set up Prisma in Next.js project, and it basically sets up the type definitions for Prisma using the extension accelerate package that I mentioned in the beginning of the video. Whenever you want to set up a Prisma client or a Prisma object in your project in Next.js, always just copy and paste this, and you don't have to worry about it. It just sets up the types for you so that you can use your Prisma client. Now we can go back to our auth.ts and we can import Prisma from /lib / Prisma, and we have access to the Prisma client. Now down here, we want to export const and then call the next auth function. Then what we're going to get back from this is we're going to get back a couple things. The first thing we're going to get back is an auth object. It's a function actually, which we can use to call whenever we need to know if a user is authenticated or not. So we literally just call this auth function and it gives us back the info if a user is signed in or not. So it's very simple for us to get the session. Then we also need to have access to the handlers, and you guys will understand why later. Then we need a sign in and a sign out function. This is all provided to us by NextAuth, and obviously, as you can see, we're going to be using this to sign in a user or sign out. Now, inside of here, we have to specify the session strategy, and we're going to be using JWT for it. So I'm going to say strategy is equal to JWT. Then below here, we want to specify what providers are we using to authenticate. So providers, obviously by the name, it implies that we're using GitHub, right? And if you're using GitHub or Google or Outlook or whatever you're using, you'll pass all of them into the list of providers. In our case, it will just be GitHub. Then we want to pass on an adapter. Now, why is an adapter necessary? Well, it's only necessary if you're using some sort of ORM that will store information in a specific database. So in this case, our adapter is Prisma because that's the ORM we're using in this video. So we want to pass the Prisma adapter, and in the same time, we want to pass the Prisma client inside of here. And it will automatically handle all of the authentication, creation, all of that stuff for us when a user signs in. Then we want to implement a callback. So what is a callback? Well, callback functions are functions that you can define to control what happens during the different stages of authentication. In this example over here, we're going to set up two different callbacks. The first one is going to be a JWT callback, and I'll just make it like this. And then the second one is going to be a session callback. Now, what do they mean? Well, this JWT callback is a function that is going to run after a user signs in and only once. So when we run this, I want to first of all just make it async. So I'll make it async like this. I'll have access to the information about the user's JWT. The name JWT is not invented. It's a name of a function that we can set up as a callback function from NextAuth. So we have access to the JWT token and also the user info. So when we set this up, we want to check only if the user actually is available at login. We want to add some extra properties to the JWT token, just because we want to make sure that we have access to those properties when the JWT token is stored in the browser. So I want to add a couple things to this token. If you're not familiar with JWT authentication, then I wouldn't worry too much about this. I would maybe just watch another video on JWT. I have videos on it. It's like a whole different topic. But to be honest, in today's day and age with something like NextAuth, you don't really have to worry that much about it. It does everything simply for you, but we're just storing some information into a token. And in this case, we want to keep track of the user's ID. So we'll create a type called ID on the token object, and we'll set it equal to user.id. And we'll do the same thing for name so that we have access to that as well. So we'll say user.name. Perfect. And in the end, we just want to return the token. Now for the session, we'll be able to access the same kind of information over here. So the first thing we can access is the session and also the token. And because we now have the ID and the name in the token, we can assign those values to the session as well, which aren't things that are by default in the session object. So what we want to do is if the session.user is valid, then we want to set session.user, and then you see that the only things we have access to over here is this. We want to set the ID equal to the token.id, and I want to set that, I want to cast that as a string, and we want to do the exact same thing to name. So we're going to say equal to token.name and also a string. In the end, we're just going to return the session, and this is going to be fine. Now, whenever you set up a NextAuth object like this, I highly recommend always setting up the JWT and session callbacks just like we did. In summary, we're just enriching the token on the JWT callback over here so that it has more user info so that we can then use it later in our app. And in the session, we're just ensuring that the session returned to the client has the same ID and the same name from the JWT token. So now we're pretty much done with this setup page. We're going to close this off, and I want to also just set up something real quick. We want to create a middleware.ts file. Now, based on what NextAuth recommends, we just have to export here the auth file from @/auth, the file that we just created, and we're going to change its name to middleware so that Next.js recognizes it. So we're going to say middleware, and they're going to handle it all for us. So now let's go back over here. We need to do one final thing. When we sign in with GitHub, NextAuth is going to reload us or redirect us back to somewhere in our page. And to have that working, we have to set up the API route. And on this API route, we have to have a folder called auth. And on this auth folder, we have to have a folder called /NextAuth. And on this folder, we have to have a file called route.ts. This is just based on pure what NextAuth requires us to do. And inside of this route.ts, we're going to use the handlers function that we got on this auth.ts file, this handlers function over here. And we're going to use it by importing it, so handlers from @auth. And all we're going to do is, this is going to give us access to a get and a post request that we're going to create on this file. So we're going to say handlers, and we're going to get back over here the get and the post. Perfect. Now I'm going to close this off, and now we can finally start implementing our sign-in functionality. To do that, I'm actually going to create a new file inside of our lib over here, and it's going to be called auth. This is going to include all of our server actions that are going to actually allow a user to sign into an account. So if you remember, we had here the sign in and sign out functions from @/auth. So we're going to use those. We're going to get a sign in and sign out. Now in here, we're going to export const two functions. The first is login, which is same thing as sign in, but I'm going to keep it like this so we don't have double imports. And the second one is going to be a logout. So we'll just call it logout. Now on this login, we're going to await, and we're going to call this sign in function. Now the sign in function, we have to pass first, what is the provider we're using? And you see there's a billion of providers that NextAuth allows you to use. But in our case, we're going to be using GitHub. Then we need to pass where is our user going to be redirected to after the user signs in with their GitHub provider. So we have to put a redirect to route over here, and we're going to put just redirect them to the empty, like the index of our page. So we'll keep that. Then we're going to come down here, we're going to await, and we're actually going to sign out. Now sign out doesn't really have to pass a provider because you don't sign out with GitHub, you just sign out. But we do want to put a redirect to so that the user knows where to go. And the redirect to that I'm going to put is the auth/sign in, because when they sign out, I want them to sign back in. Now we can come to the sign in page, and we're going to add an on click to this button. Just going to say on click, and we're just going to call the sign in function. So I'm going to say sign in, and we need to import this function. So I'm going to auto import it, and then we want to log in. So I'm going to call the login function, and this should be good to go. Now it won't work yet. And the reason for that is because there are a couple environment variables that we have to set up. The first one is this auth secret that is required by auth.js. And the way we generate it is we just run npm exec auth secret, we press enter, and it will automatically create a .env.local and add this auth secret for us. We don't have to touch it, but it generates it for us. Then what we need is we need to add a GitHub auth provider. So to do that, you have to go into your GitHub account. You have to click here and go to settings. And then in settings, you go to the developer settings. Now I'm not going to click on it and show you guys because when I click on it, actually I will, but I won't click on OAuth apps. You just have to go to OAuth apps, and I just have a bunch of them and I don't want to show all of my OAuth apps, but you click on this and you click on new OAuth app. Then when you do that, you'll be granted with this page over here, and you want to generate a client ID and a client secret. I already have them. They're over here. You see I added this 3 hours ago, and I'm going to be using them. I'll delete this project right after so you guys don't use the same as mine. But when you're done getting your client ID and your auth secret, we go back into our .env.local over here, and we add both of those. So I added here an auth underscore GitHub ID and auth underscore GitHub secret, and just having them like this, you don't have to do anything else to it. Just name it exactly the same and keep them on the .env.local. Next auth will automatically get those and handle adding those to the GitHub auth provider. So now we're pretty much good to go to allow a user to sign in. Let's see if that works. So I'm going to come here to our project. We are seeing an error. I'm going to see why it's erroring. So I found the issue. The issue is that on our auth.ts, we're not going to use the Prisma instance that we created over here. We're going to use that for everywhere else in our project. But in here, we actually want to manually import the Prisma client from the app generated /Prisma. And then we want to create an instance of it. So Prisma is equal to new Prisma client. And now if we go back here, you should see that we see again the sign in page and that error is gone. So now we're able to sign in. Let's check that out. I'm going to click on this button, and I'm already signed into GitHub, so it should be automatic. And all of a sudden I'm in the home page now. We don't see anything visual yet, but the way we can check to see if the user actually signed up is we can go and see if any data was added to any of these tables. For example, as you can see, a user was created for Pedro with their email, their profile picture from GitHub, and other stuff as well. Not only that, but an account has been created as well. So we know that the user has successfully been created. Now we just have to have some UI to show that this user is actually authenticated or not. So let's go back over here and let's make that happen. Starting off with the nav bar, which is something that we have already made. First of all, I don't want to see the sign in button when the user is already signed in. I want to see this become a sign out button. So to do that, I'm going to want to have access to whether or not the user is signed in or not. So I want to know about the session of the user. But this nav bar over here is actually a client component. I know we haven't made it into a client component yet. We're going to do it right now. But it is a client component because if we want to have a button to log out the user, we're going to have an on-click on that button. So this component has to be a client. Now in client components, it's not easy for us to just get the session of the user. To do that, we actually have to create a session provider that we're going to distribute so that we can access the session in every single client component. To do that, we're going to make here a file called a session provider. It's going to be a TSX file. And this is actually a provider that is given to us by NextAuth. So we just copy and paste it over here. It just creates a component called session provider, which takes in a session and then provides it to every other children inside of it. We want to use this in our layout component over here, because in the layout, we can wrap around our entire project with this session provider, and now all of our client components, or every single component, will have access to it as well. But the thing is, in order to pass a session provider, we need to provide it with a session, right? And the way we're going to do that is by using the actual way to get a current session, which is our auth function. So in the root layout over here, this will become a server component. So it's going to become an async function. We're going to get the session by using the auth function. So I'm going to create a session variable, set it equal to await auth. And remember, auth over here, I'm getting it from the auth file that we created. And now I can pass this session to the session provider. And if I want to access the session information of whether or not a user is authed or not in a client component, all I have to do now is I can use this use session hook from NextAuth, and it will automatically provide it with the necessary data. Now I'm going to change this value to be called session, that we can use it more properly. And the way I want to differentiate this is, let's think of the links and buttons that should appear when a user is authenticated and the ones that shouldn't. So for example, browse jobs, sure, a user can browse jobs even if they don't have an account or they're not logged into their account. But to see a link to post a job or to the dashboard or to sign in doesn't make sense if the user is not authenticated. So what I want to do is I want to wrap around this two over here. Forget the sign in, that's actually what you want to see when you're unauthed. And in here, I want to check, is session valid? Is it null? Because if it's not null, then we want to see those links. And since they don't have their siblings, I need to put here a fragment to wrap around them. Now I need to put an else condition, and the else condition is that the session is not active, meaning they're unauthenticated. Then I can put this link over here. So we see the sign-in page. And you can see now that if I go over here, we don't see anything because it's failing something. Oh, I just need to refresh. But yeah, we see all of this, but we don't see the sign in button. So what we want to do now is allow the user to sign out. So below this dashboard over here, I want to add this button. It's going to be a button that has the following class names if you want to apply the styling, and it says sign out. And again, it's inside of the session gating. Now the logout button over here, we want to import that function. I don't need to make it into a callback function. I can just do it like this and it should be fine. And now when we go over here, we should see the sign out button instead of the sign in button. When I click on that, we should now be redirected to the auth/sign in. And if I refresh this, we should now see that those states updating. Now let's create the posts, the job post component. So we have a page that is going to allow us to browse through the jobs, but we also, to actually see any data, we're going to create the create job route first. So in order to do that, I'm going to create here a folder in the app folder. It's going to be called jobs. And in this jobs folder, I want to create not a file, a folder called post. And this folder is going to have a page.tsx. And then when we create a post, it's going to be inside of this page. So we want to create here a default function called post job page. And in here, we want to add the following UI. So you see here, we have the UI. It includes a title for this page that says post a job. It includes a form. And the biggest part of this page is going to be a form. The form includes an input for the job title, an input for the company info, an input for the location in which the job is, an input for the job type, which turns into a select with 4 different options or 5 different options, right? And then also a text area for a description, an input for the salary, which is optional, and a button to submit the form. Now, the reason why I just skipped me making that is just because I don't want to waste time with making that UI. So we're going to sign in with GitHub over here. We're going to go to post a job, and we should see that this is how the UI looks like. So looking great. Now, I want to show you guys how to implement the functionality to actually create a job in our table by using this form. So to do that, we're going to come back here. And this is a form, so we need to create a handle submit function for it. So at the top over here, I want to make a const handle submit is equal to async. And I'm making this function that is going to take in an event, which is a type of form event, HTML form element. And inside of here, I want to first prevent default so the page doesn't refresh. And then we want to import this from React. And we want to get back the form data from this form. So to do that, I'm going to say form data is equal to new form data. Then I'm going to say e.currentTarget. And through that, I can construct this object called data. Now, this object is going to allow us to define how the data is going to look like when we send it to our Prisma client. So if we look at the model we created, actually, we can look it over here, right? A job has, let me go down. It has a title, a company, a location, a type, a description, and a salary. The posted at, posted by, and posted by ID, and the applications, it's all things that we don't necessarily need to pass ourselves. So when we create a job, we're going to do it like this. We're going to say the data is going to be a title, which is going to we're going to get it through the form data object by saying .get, and then we specify that we want to get the title input with the name title or the ID title. So we say title over here, and we can do the exact same thing for the other ones. I can do it, for example, I'll do it here for the company, and we can get the company. Now, when you're done adding the other ones, just the exact same way, we can send this data through an API request. So we're actually going to be using API routes for this. We're going to make here a new API route in our API folder. It's going to be called job, or more specifically, we can just call it jobs actually. And in here, I'm going to make a route.ts. Now on this file, I want to export an async function called post, because this is going to be a post request since we are going to be sending some data to our table. Then we're going to get a request. And inside of here, the first thing we want to do is find out and validate if a user is authenticated or not. This will ensure that not only we are validating that on the client, but also in our server endpoints. So we're going to do that by, again, using the auth function from NextAuth. So we're going to import that, and we should be good to go, because now if there isn't a session.user, not session storage, a session.user, and or in this case, let's actually also ensure that there is a session.user.id. Then we return a new next response dot redirect the user to the /auth/sign-in page. Now I need to turn this into a new URL, and I need to pass the request URL inside of here. So I'm going to say request.url. Perfect. We're just redirecting. Now I don't need to return a new actually. I'll delete that. And in here, we are going to try and catch. And in the try, we're going to get the data from the body. So we're going to say await request dot body. Actually, not dot body. Let's do it dot JSON. Then with this, we're going to get back the data. Now with this, we're going to get this object that we got from here that we're going to send it. And this isn't necessarily the entire object. We need to also pass the posted by ID. So to do that, I'm going to actually call directly the Prisma client. So we're going to say Prisma, which we can import by getting the Prisma object from lib/Prisma. We're going to say dot job to specify that we're interacting with the job model. And we're going to say dot create. We've dealt with this before in the start of the tutorial. To create, we just have to pass a data. And in here, we already have a lot of the data because we're going to get that from the JSON through the body that we're going to send. The only thing that we are not going to get is the posted by ID. So what I'm going to do is I'm just going to destructure the data. Now I also need to pass here the posted by ID, right? And this is going to be equal to the session.user.id. Now when this is done, if this is successful, then I want to return the next response.json with the new job. Now let's handle an error. If there's an error, it's going to be pretty simple. We're just going to console log or console.error. And we're going to say error creating job, and we'll specify which error it was. Perfect. Then down here, we're just going to return a new next response, and we're going to say internal server error. We'll put a status of 500. Now this means that we can call this endpoint in our onSubmit on the post job page. So in here, we're going to try, and we're going to get a response. We're going to await, fetch. We're going to fetch /API/jobs, and we're going to pass in a method, which is going to be a post method. Then we're going to pass in a headers, which is going to be content type, and then we're going to pass in application/JSON. Then we want to pass the body, and the body is not going to be actually inside of the headers. That's an accident. We're going to put it down here, and the body is going to be a stringified version, so json.stringify of our data. Perfect. Then we don't really do anything with the job response. I'm actually going to even remove that. We don't do anything with that. I'm actually going to just catch this, get any errors. If there's an error, I'll just console log it. So let me just console log the error. And finally, I want to pass this handle submit into the form. So we'll go to the form over here at the top. We're going to add a onSubmit, and we're going to pass the handle submit here. Now I want to make this into a client component. So we're going to say use client at the top, and let's try this out. Let's go to post a job. Let's create a new job. I'm going to create one, and I'll be back in a second. So as you can see, I created here a job. It's a software engineer 1 position at Amazon in Texas. I'm going to click on post a job, and if everything went right, we should see that information. So it's empty. And I found out the issue. So the issue is that we forgot to put in a wait right before the Prisma call. So let me try that again. Let me try closing this up and clicking post job. And if everything worked, we should see now, yes, that data was added into our table. Also, I just realized I wrote software wrong. So let me change that. Save change. Perfect. So now we have successfully added that into our table. So what I want to do as well is I want to redirect the user after this is done. So to redirect, I actually want to come here to this, and I want to, after we fetch the data, I want to just redirect the user. The easiest way for us to do this is just to say window.location.href, and I'm going to redirect the user to the /jobs route. Now I have already added here a new user. It's a consultant, and to create this user, I'm going to click post job, and if everything works out, we get redirected to the jobs page, and we should see here, if I refresh the page, that the consultant was added to our table. Perfect. Also, in the meantime, I added another software engineer. I just didn't show you guys. But yeah, so now we have successfully created another job. Now let's set up the ability to browse jobs by showing a list of the jobs that are available and also allowing the user to search for them. So to do that, we are going to come back to our page over here, and we want to add a new route. Now this route is going to be on the jobs route, but it's not going to be a post, so it's going to be outside of the post folder. And we're going to add a page.tsx here. Now in this page, let's create a default async function called jobs page. Now in here, we want to return, and I'm going to paste what the UI is going to look like. So this is what the UI is going to look like. It's going to have a title for the page. It's going to have an input and a select for us to query for the different items in the page. Also, we're going to loop through the list of jobs. Now, I commented this out because we don't have yet the list of jobs. We're going to have to write an API request for that. So I'm going to do that in a second. But you can see that we're going to loop through the list of jobs, and we're going to render each job as a card. Now, nothing really shows up. Only the search functionality shows up, but it obviously doesn't work yet. So what we want to do is we want to first add the ability for us to fetch all of the jobs available on our table so that we can actually uncomment this and loop through them. So to do that, I'm going to have to go to our route.ts, and I'm going to make a get request inside of this route. So we're going to copy this whole thing over here. We're just going to paste it down here, and we're going to make a get request. Now this get request is going to be different. We're going to delete most of these. We're going to leave the try though. So let's add the try here. So we're going to leave the try catch, but it's going to be different because there's a lot that is going to go inside of this. The user doesn't have to be authenticated to actually run this request. So we don't have to get the session. But what we want to get is the list of jobs. So I'm going to say const jobs is equal to await, and we're going to use the Prisma client. We're going to say .job and then .findMany. Now, if we don't put any condition here, we're going to get all the list of jobs in a random order. So what we want to do instead is we want to put a condition to order our data. So what we want to do instead is we want to add a condition to order our data. And we do that by adding an order by property over here, which allows us to specify a datetime field like the posted at, and say that we want to order it based on the posted at in a descending order. So we get the newest jobs first. Now, when we're done getting that, I'm going to return the jobs. And now if we go to the jobs page over here, we can now fetch that data. Now, to get the data for the jobs, we're not going to do them in the same way we did here with the post request, just because I think it's going to be easier for us to just manually interact with Prisma directly on the component. This is going to be a fully asynchronous component, so we don't have to actually make a fetch request. We can just access Prisma directly here. So what we're going to do is inside of this component, we're going to say const jobs is equal to await, and we're going to await prisma.job.findMany. So this is going to give us back the list of jobs. Now we can uncomment this, and you'll see that when I get back the list of jobs, I still need to comment this part out, sorry. We can go to the page and we will actually see the jobs being listed out. Now there isn't any particular order to them. What I want to do instead is I want to order them based on the dates in which they were posted at in descending order. To do that, in the findMany, we can put here an order by, and we can specify that we want to order it by the posted at field in a descending order. And now you should see that it's exactly what it shows. It shows the newest jobs posting first, not the first one to be created like it was before. Not only that, but I also want to know like the name of the user who posted this job. We have here some UI that does that, right? I just commented it out. Now this UI gets the job posted by .name, and it also gets a link, but it's just because I need to import that. That's why the error was saying that there was an error, but I just imported it. But where is this posted by property, right? Because if you look closely, the type for job doesn't have a posted by. It does have a posted by ID, and but it has a relation. If you remember correctly, it does have a relation because we created it over here. There's a posted by in a job that includes a user. Now, how do I access that relation and make it such that this job will now have the posted by property, which then will then consequently have the name? Well, to do that, to include a relation, you come to the find menu over here, and you want to include, and you specify which field. So I want to include the posted by, so I set it to true. And now all of a sudden we can access the posted by, because now the job parameter over here include the user as part of the posted by property. So now if we go here, you see that if I refresh this, it should include the name of the user that posted this job, which in reality, it was just me. So perfect. Now we have successfully showed all the jobs, but how do we do this little thing over here? This is a little bit complicated, but I think it will introduce one of the last and really crucial parts of Prisma that I haven't mentioned yet, which is working with different queries. So it's going to be a little bit complicated. If you're not going to use this every day, it's only when you're going to be working specifically with queries like this, where I want to search my database based on some criteria. In this case, I want to first search based on name. I want to be able to write here software, and then both software engineering positions are the only ones that show up. I want to maybe be able to search for only full-time or only part-time positions, and or location or positions in a specific location. So the way I do this is I want to use actually this form that we have over here. If you've noticed, we don't have an on submit to this form, and we do have a button to submit it. Now, what I want to happen is when I write a job here like software, and then maybe I put full-time, and then I don't specify a location, and I press search, you should see that the only thing that happens is we now have this param that's changed on our screen, right? The param now has a Q value for the query with software, has a type for the full-time, right? And it doesn't have any location. We're going to use that as the information we're going to pass to our Prisma query when we fetch the data. So what we want to do here is we want to get the information of what is in the params. To do that in Next.js, it's actually pretty simple. We're going to come to the arguments over here of this, the props of this component, and we're going to destructure the search params. Now we have to give it a type, and the type is going to look a bit weird, but you will understand what I'm doing. We're going to define the type as search params. Then in here, we're going to pass a key of a string, and the value will be a string or a string array or undefined. So this is what we need. Now, this will also return a promise. And this is something that people forget, because I believe it only started being like this after Next.js 15. So it returns a promise, and to get the search param, we have to say const, set it equal to await search params. And in here, we can now get the Q, the type, and we can get the location. Those are all values that are going to be in the search param. Now, what is Q? Q is query, and that's why we named the first input Q, but you could call it whatever you want. That's why we named the second one type, and that's why we named the last one location. Now, we want to use that to our advantage. So what we do is we say, when we are finding all of the jobs, we want to find the jobs where, and this is where it gets a bit complicated, we want to put an intersection using an and, because we are like, when I search here for a specific position like software, and then I also include a full-time over here and I click search, I don't want to search for every software position and every full-time position. Now I want to search for a software position that is also full-time. So as I introduce more of this search params, I want to make an intersection of them so that we get a more concise result. So in here, what I want to do is I want to put an end, put an array, and then we'll write all of the three queries. So the first query is going to be the Q. So if Q is equal to true, then we want to implement a query for it. If not, then we're just going to put an empty object. So that's just because we need to account for the fact that maybe there isn't a query here in the URL, which happens, right? Right now, if I go to the page, there's nothing in the URL. So that should be fine. We shouldn't just error that. So what I'm doing is if there's a Q value to the search param, then I want to search for a job where the title contains the query. So if it contains that value that we're searching, like in our case over here, when we search software, we want to check to see if it includes the word software. Now we also want to make it insensitive so that it doesn't matter if the user wrote a letter or two in caps, it's insensitive. It doesn't, like, it accounts for everything, right? Now, we don't want to just search for the title. We also want to allow it to also query for information, for example, on the company name and on the description. So instead of just making title like this, we actually want to make this into an OR and wrap this around with an array such that now we can search for queries where the title includes the query, but also that the company name includes the query. I'm gonna just copy and paste it here because it's gonna be the same. And I'll put the same thing for the description of the job so that it not only accounts for example, the description of two of the jobs include the word React, GraphQL, and Go. If I search GraphQL, I want it to also show jobs that have that in the description, not just jobs that have that in the title. So this is a way for us to expand our search. Now it's giving us a bunch of errors, but that's perfectly fine. The way we're gonna get rid of these errors is we're gonna put a comma here so that we can actually add more items, since this is an array and it's an intersection. But also because maybe we have to cast a type to the queries specifically, right? So actually what I want to do here is I want to create here a query variable. Let's see if this will fix it. I'm going to set it equal to Q, but I'm going to say as string or undefined. And then I'll just use query instead. I'm just casting this type to it because sometimes it has issues with this kind of stuff. So let's pass query, query, query. And yeah, that totally fixed it. It was just the type casting because we defined it like this. And when we're getting stuff from the search param, sometimes there's no type definition. So then we want to pass the next query. So now we're able to search for the user. Let's try this out. We can search for the name of the thing. I just need to put a comma here. Let's see if this is working before we add the other ones. If I click software here, let's see if the consultant one disappears. And yeah, it disappears because it gets the query for software and it keeps it. Now let's try actually searching for, let me refresh this, right? And let me search for stuff. So stuff is in the description of consultant. So if I search that up, yeah, it detects. If I search Deloitte, it detects this as well. And so it's working. Perfect. Now let's add the rest of the queries. Let's allow user to query for the type. Now type is going to be a little bit simpler because it's literally just the type. So we're going to query if type is not null, then we want to query items where the type is equal to the type. If it's not null, if it is null, then we don't want to query anything. So literally, this is all it's doing. We actually have to get the type, similar to what we did here with the query. We're going to call it type, and I'm going to, actually, we need to call it search type. And we'll change this to type. Perfect. Now, let's see if it works. Let me search for only contract jobs. Yeah, it's working perfectly. Now, finally, let's add the last one, which is going to be the location. So we're going to say if location, which we also have to do the same thing here. Call this search location, and we'll pass location here. If search location is not equal to null, then we'll do something. If it's equal to null, we'll do nothing. If it's not equal to null, then I want to search for the items in which the location contains the search location that we just passed. And we want to do the mode insensitive in the same way. So that if I now come here and I search for positions in Seattle, I can write Seattle here, and I'll also write it in lowercase, even though it's in caps lock over here, and it will detect that this is Seattle. Perfect. Now we have successfully implemented a really cool search param inside of our a search functionality inside of our browse jobs page. We can search for all of these and it actually detects and get the information from our database. This is actually pretty cool. Now we pretty much have this page done. I feel like it's time for us to make the page for individual details. So when I click on this, I want to be able to be brought to a page where it just shows that specific job and it allows the user to apply for that job. So to do that, what we want to do is we want to come to our project. I'm going to create here another folder, and this folder is going to be inside of the jobs folder, and it's going to be called ID. And we're going to make it like this because then we can pass a param, which is going to be the job ID, as a param to that route. Then inside of here, we're going to make a page.tsx. Now I'm going to export default async function, and we want to make a job page function. Now, like the search param component that we just did, this is going to have a param. So params, the way you do it is you do it like this. You define the params type, and then you give it a type of a promise, and you specify what the param is that you're going to pass. The param we're going to pass is called ID, and it will be a string. Then we're going to get back that param down here. So the way we're going to do that is we're going to say const job ID is equal to await params.id. Then I want to get the specific job that associates itself with this param. So with this job ID. And again, we're going to do this locally just because I don't want to deal with having to make like a fetch request to an API route instead of a use effect, because in this video we're not using something like React Query for simplicity reasons. So I want to make the request directly here. And to do that, it's actually pretty simple. I can just say const job is equal to await prisma.job.findUnique, because we want to find one job using one of its unique properties, and the unique property we're going to use is the ID of the job. So we're going to say where, and then we're saying ID is equal to params.id. Actually, we already have the job's ID here, sorry. So job ID. Then we also want to make sure that when we get the job, we do the same thing we did here with the list of jobs. We include the information about the user who posted it. So we include the join that we did with the user table. So we say include posted by, and we say true. Perfect. Now we want to detect if no job was found. So if no job was found, then I honestly just want to set a not found, because then this means that this ID that we have on the URL isn't a valid ID, meaning that I'm going to call the not found function, which basically triggers and forces me to be redirected to the 404 page not found that exists in our project. Now I'm going to paste here the return UI for this page. So this is the UI we have here. We first have a link to go back to our previous jobs. So I'll click here on one of them and we can see this. So we have a link to go back to the previous jobs. We have the title, the company, the location, the price, and so on, and also the job description. We render all of that simply by just using the information we get back from the job we just fetched. Now, one thing I want to show you guys as well really quickly is that we use the format distance to now. What this is a function that I just imported from datefns, and it will basically grab the date time that we got from the posted at, and it's going to format it in a way that looks pretty nice. Like for example, about 2 hours ago, instead of, just literally being a timestamp over here. So that just makes it look a lot better. And we have this page. Now we want to add the ability to click on a button down here and apply for this position. So to do that, I'm going to come down here and I want to call a component we're going to create called the apply button. Now, the reason why I'm not just making the UI here and I'm making a whole other component for this is because remember, in order to fetch data from Prisma, we need to make this into an async component, meaning a server component. And whenever you have a button, it's by default a client functionality because it requires you to pass an on-click for when you click the button, and an on-click only runs in the browser, so it has to be in a client component. So we're going to have to make a client component called the apply button, and we're going to pass the job ID to it. So we're going to pass job.id. And let's create that component. I'll just create it directly over here. We're going to call it the apply button.tsx. And the first thing we want to do is turn this into a client component by saying use client. Then I want to export default function apply button. I'll pass here the job ID as a prop, and the job ID prop is going to be of type job ID, which is a string. Then we'll open and close this. And the UI for this, I'll manually write it. It's pretty self-explanatory. This is going to be a button. So we're going to make here a button that, depending on that, will say apply for this position or something like that. Now, whenever you click on this button, I want to call a function called handle apply. So we have to create that function up here, const handle apply, and it's going to be an async function. And when you apply for a job, the first thing we need to make sure is that we gate the ability to apply for a job if you're not signed in. So I'm going to use the use session hook that we created in the beginning of the video, since this is a client component. So use session. We're going to get back over here the data, which then gives us a session, and it also gives us the status. Now the status will basically gives us the information of whether or not we are currently fetching the information about the session. So technically, if the status is equal to loading, what we can do is we can just return the same button, but it will say, instead of being clickable, actually it will be disabled because you can't click on it, and it should say something like loading. While the data is fetching this, it will show loading. So we can go back over here, and in the handle apply function, the first thing I want to do is check the session. So if no session, then I want to actually be redirected. So I'm going to use the router from use router by next navigation, and I want to call router.push. Now what this router.push will do is it will just redirect the user, and if the user is not logged in, I just want to redirect them to the sign-in page. Now if they are logged in, also I want to return this. Now if they are logged in, then I want to try to make the application work, and if it fails, then I need to catch any errors. Now for catching any errors, I'll actually show the error. So I want to create here a state called error message and set error message. I'm going to set it equal to use state. It will be a string. So I'll make this a string type. And when you are applying, we'll just reset the error message in case you applied once, failed, and then try to apply again. And then if there's an error, then we're going to set the error message equal to, and then we're going to actually, let's do this. Let's check first to see if error, the error that we get is instance of error. Because if it is, then what I can do is I can just set it equal to the error message. So error.message. But if it's not, then I can just set it equal to, I'll do this, and I'll set it equal to set error message failed to apply for the job. Perfect. Now, what do we do in the try? Because in the try, we're going to actually apply the application, right? We're going to actually add the application to the application table. Now, to make that happen, this time I'm going to do it similar to what we did with creating a post. We're going to create an API route that is going to handle that. So in the API/jobs folder, we're going to create another folder, which is going to be called the job ID folder. And then inside of here, I'm going to make an apply folder. And inside of the apply folder, I'm going to make a route.ts so that the endpoint is going to be /jobs/job ID or whatever you insert there /apply, something like that. So now in this route, what do we do? Well, we're going to copy some of the logic we did here for the post request, because it's going to be very similar. we're just gonna paste it over here. And we're gonna keep it as a post. We're gonna keep this session. Now from the request here, we also need to get the params. So to get the params, we're gonna do the same thing we did with the components. We're gonna grab the params here, set it as a type equal to params, which is a promise. And then we have to specify what the type of our params is gonna be. It's gonna be job ID, which is a string. Now inside of here, we get the session. If there's no session.user or session.id, we redirect them. Then we need to try to find a job with a unique ID so we get the job specifically. And then what we need to do is we need to get the job ID to try to find the job, because if the job ID that is on the param of this request is not a real job, then we want to know. So we first need to try to find a job in the job ID with that job ID. So I'm going to say await prisma.job.findUnique, and where the ID is equal to, and then we need to destructure the param. So I'm going to say const equals to await params, and we're going to get back the job ID. So where the ID is equal to job ID. And if that's the case, which by the way we have to do this, then if no job, then we want to return a new next response, and it's going to be a job not found error, which we're going to put as an error message. So we're going to say status 404. Now, if the job is valid, now we know, we have to also check to see if the user already applied for this job. So we're going to do const existing application is equal to await, and we're going to now make a find request to the application table. But we're going to use the find first just to see if there's any application existing already in between this job and this user. Then we're going to get the first one. It doesn't really matter, right? There can't be any application existing if you're trying to create one. So we're going to say find first, and we're going to specify that the application has to have the job ID equal to the job ID that we have on this request, plus the user ID has to be equal to the session.user.id. And if that's the case, so if existing application is true, then we want to also return an error. This error will say you already have applied for this job, and it will say status 400. Now, if none of that is true and we're still in this request, we want to finally create the application. So we're going to say application is equal to await prisma.application.create. And in here, we're going to pass a data, which will include the job ID, which we're going to obviously pass the job ID here. Then it's going to have a user ID, which we're going to pass the session.user.id. And remember, we also have to pass the status, right? And by default, it's pending. I'll just pass it as well. So pending. Now, when that's done, we want to return back this application as a new application created. Perfect. I'm also going to remove this console log. Now we can go back to the apply button. And in here on the try catch, I'm going to make a request. I'm going to get back the response. I'm going to await fetch, and we're going to make a request for the /API/jobs/ and then I'll insert the job ID here, and we're going to pass the apply as well. Now we have to specify that this method is a post. So we're saying method is equal to post. And when we get back this response, I want to actually notify the user that it was successful. So I want to create here a state called application status and set application status. The only reason for this is just because I feel like there's so many errors that can happen with creating this application. There's so many times where you can fail that I think it's better for us to do something like this, where we're going to actually make this state be a status of the application. So initially the status is idle, meaning that the user is still applying, there wasn't success or error, but this status can be either idle or success or error. And then what I can do is when we successfully fetch the data, I can set it to success. And when we get any errors, I can set it to error and so on. So also I want to refresh it actually. Similar to how we did here with the set error message, I want to set the application status to idle. Perfect. Now let's just update the UI to reflect this. So after applying, if there's any errors, so if application status is equal to error, then I want to render a p tag that is going to render the error message. And that's how we handle showing the error. But if the application was a success, then I want to replace this apply button altogether. So if application status is equal to success, I want to make this return a div that is going to have a p tag saying application submitted successfully. And then down here, I want to put a link to the view your applications page. And then I'm going to import this from next link. And the href we're going to put is the href to the last page we're going to make, which is the dashboard page. So let's test to see if this works. I'm going to come here to the page. We have nothing on our actually, I haven't put the UI yet. That's actually a good point. So I'm going to copy and paste the CSS for both this and this. Actually, we already put it for this, but I'll put it for this and I'll be back in a second. So I just pasted here the UI. You can take a look. It's pretty simple. Also, I realized I wrote error wrong. So I have to update that over here. And I think it should be good to go. So let's go back to our Google Chrome. Oh, I know an error already. So this should not have this. So let's go back here. Let me apply for this job. When I click on this, we should now see that our application submitted was successful. So when I click on view your applications, we should now go to the dashboard, which should show the applications I've had applied. But we know that the application was successful because if I refresh this, we now see the application over here. Now let's make the dashboard. I'm going to come here to create another page on our project, not in the API folder, on the app folder. I want to make the dashboard folder. And in here, let's make the page. And in here, let's make the page.tsx. And then let's export default async function dashboard page. And I'm going to first get the session, which I need to, this is going to be a server component, so I can just await auth. Then I want to detect to see if the session is valid. So if the session is not valid, so if user.id, I specifically am searching for the ID just because I need it. I'm going to actually redirect the user to the auth/sign-in page. Now, this is not the redirect function I want. I don't know why this keeps auto importing. I hate that from Next.js, but yeah. So now I'm going to paste the UI for this page and I'll go by each step of it so you guys can understand. So here it is. Now I commented out a lot of it and I'll explain why. This is the dashboard page. If you remember from the demo, in the dashboard page, we have two different sections. We have first the section where it shows the posted jobs. So like all of the current jobs, similar to the browse jobs section, it shows a couple of them. And then we have a section for your application. So it shows literally your applications and like which ones you have applied and their statuses. So in this component, we need to do something a little bit different where we get different types of information at once. So to do that, what I want to do is actually, I want to use a promise.all to make to request two promises at the same time. So I'm going to say promise.all and it will return an array back with the two promises. The first one is going to be the applications. So we get back the data of which applications we've had applied for, and also just the general posted jobs. Now in this promise.all, we also have to pass which promises we're going to have here. The first one is going to be Prisma.applications, and we have to import Prisma. So let me import it. So Prisma.applications, and I want to, or it's actually application dot, and I want to find many. Now we're finding many because we want to get multiple of them, and we want to make a very specific request for it. Now, what request do we want to make? Well, we want to get the applications where the user ID is equal to the session.user.id. And that's why I specifically gated for whether or not this is valid. Now, after this, I want to make sure that when I get the application, I also get the information about the job. So like if you look down here on our model, right, in the application model, we don't have really any information about the job, only when we make the relation, right? We can't do anything with the job if we just have the job ID. So what we have to do is we have to say that we want to include that information. So I'm going to include job, and out of the job, I want to specifically include the posted by. So we get the user information directly from the job information. So we're going to get that, and we're going to set it to true. So we also get information about the user who posted that job that we applied for. So it's like a continuous, like it's a triangle, right? It's not a triangle. It's just a stream of us getting the relations, right? We're in the applications, we get the job, which then leads us to get the user. Now, after this, we have to order the applications. So I want to order it based on the applied at to get it in order of which applications we applied recently. So I'm going to set it applied at, and we're going to set it in descending order. And this is pretty much the applications query. Now we want to make the jobs query, which we have already, kinda. So we're going to do prisma.job.findMany. But we're going to do a where, and we're going to specify that it's based on the posted by ID, and we're going to use the session.user.id. So in our dashboard, we're only getting the jobs that we posted ourselves. But we want to use this cool special Prisma field that allows us to count related records. It's like not a real column in our database, but it's a virtual one that Prisma is going to add. And what that's going to allow us to get access to is whenever we get a specific job, we can now, that we created ourselves, we can now also get the count of how many people applied for this job. So to do that, we use the include property again, but then we use the special count property, and we have to select what count we want to count, right? So which field we want to count. And in this case, we want to count applications, and we're going to set it to true. And this is going to return a number of how many people applied for this job that we created. Now, below this, let's also order the jobs based on the posted at and in descending order. So now, if everything works fine, both the applications and the posted jobs should work. Let's start with the applications. So with the posted jobs, sorry. So I'm going to uncomment this. We also need to import the format distance to now that I already explained. But basically, we just loop through the posted jobs and we render each item individually. And then to get the count, we just say job_count.applications. And this will give us back the count of the applications. And you can see that we now have the count for the applications. So now let's see what happens with the actual applications. We want to see the information about the applications we have applied for. So I'm going to uncomment this. And if everything works fine, yes, we should now see that we have the only application that we have applied for. Also, I put here links for to post a new job, to navigate there, and also links for the specific jobs if you want to check it out. So yes, this is basically it. I won't do the homepage just because it has no value to Prisma whatsoever. I do have a homepage. I'm going to copy and paste it right now. And if you guys want to put it in your project, you can do so as well. But the actual homepage that I'm going to make is going to be on, obviously, the page.tsx. and this is gonna be the code. So I'm just fetching information. It's more of what we've done already multiple times, right? But the only difference is that I'm getting the most recent jobs and I'm only taking 3, which means take 3 allows you to specify how many of this findMany you're getting back. So we're only getting back 3 jobs. So this is what the homepage will look like, right? Very simple, just reusing a lot of the stuff that we've done so far. So this is basically it for the video. I know this is a very, very project-based video, even though it's a Prisma course, but I hope the first portion of the video was definitely helpful for you guys. I hope that the rest also help you guys get more knowledge on how to actually use Prisma in a real world scenario. This video was a bit different from my other videos. Usually I skip styling and CSS. I know I always do this just because I've gotten so much positive feedback from my subscribers saying that they love that I don't waste time on that. I only show myself writing CSS when it's a UI-based video, but this video was even more abstracted in the sense that I copy and pasted a bunch of the return statements. And the reason for that is because I thought that by focusing only on the parts where Prisma was being used and fetched, and I briefly explained the UI stuff that I was building, it will make the course actually way more interactive, way more easy to digest without having me spending 30 minutes building some sort of form for you guys. So I hope that you guys enjoyed this style of teaching. If you enjoyed it, please let me know what you think of this. If you want more videos like this, where I don't waste a lot of time just building divs and p tags and h1 tags and so on, let me know. But yeah, that's basically it. If you're interested in checking out my React course, it's a React course for beginner. The link will be in the description. I really appreciate if you could check it out. I put a lot of effort into that, and I think you will really enjoy it. Also, thank you so much, Brilliant, for sponsoring this video. They really help support the channel. If you want to check them out, click the link in the description, because that's one of the easiest ways to support the channel. Just go there, check our sponsors, because they help me be able to provide videos for you guys. So that's basically it. Really hope you guys enjoyed it, and I see you guys next time.